learning about functions, you may need to know whether a function is increasing or decreasing. When we say that a function is increasing, it means that both the x and y values are increasing. Okay? Both the x and y values will be increasing. So the function is increasing if both the x and y values are increasing. Okay, so function is increasing if both x and y are increasing. Okay, I'm going to give you another way of defining an increasing function in terms of gradient. Right, the function is also increasing if the gradient is positive. Okay, so the gradient must be positive. Okay, so you can decide which way you can memorize better there, but I'm going to show you some examples just now in terms of that. I'll sketch. Right now we've done the linear, we've done the quadratic, and the trigonometric graph. Okay, the function is decreasing if the x values increase whilst the y values are decreasing. So what this means is that as long as the y values are increasing, then the function is increasing. If the y values are decreasing, then the function is decreasing. Which means we generally define increasing and decreasing functions in terms of the y value. Well, the x values, which are the input, will always be increasing. Okay? Also, the function is decreasing if the gradient is negative. Also, the function is decreasing if the gradient is negative. Okay, I'm just going to draw some sketches on the next page and then carry on. Okay, generally the x values will always increase. Okay, but the y values can increase or decrease. So your input values will always be increasing all the time, right? But your y values can decrease, right? So if the y values are also increasing, then we have an increasing function. If they are decreasing, then we have a decreasing function. If the y values stop increasing or decreasing, then we have a turning point, like in the case of a quadratic function. Right? At the turning point, you cannot say that the y values are increasing or decreasing, but they will become constant, and the gradient becomes 0 at that point. Okay? Can I carry on? Let's see how much time I have. For example, so if I give you a linear like this, don't worry about the equation for that linear function. Now, if you see a linear function like this slanting to your left, means the gradient is negative. Okay? Remember that the gradient will be negative. So m is less than 0. Since the gradient is negative, it's an indicator that the function is it's a decreasing function. Also, the y values are decreasing. Remember, when we read a graph, we start from the left in terms of the values. So as the x values are increasing, the y values are decreasing. They are becoming more negative. The y values are becoming more negative. So the y values are decreasing. So this is a decreasing function. Okay, also the gradient is negative. If you have a straight line which looks like that, then the gradient is positive. Therefore, the function is going to be an increasing function. But for the second graph, the y values are becoming more positive. As x increases, therefore the function is what? Is an increasing function. Furthermore, the gradient is positive. Therefore, it's going to be an increasing function. Generally, if you can understand the concept of gradient, you can use that to distinguish whether the function is increasing or decreasing. Okay, so this is for the linear now. For the quadratic, you just need to just draw one and talk about it. In fact, I have to draw two. But let me move on to the next page. Right, for the quadratic, remember, we have got two cases. So let's say if I draw my quadratic like that with the maximum turning point, remember the value of y at the turning point is a q. Okay, so for a quadratic function with the maximum turning point, okay, it will be increasing to the left, okay, the left of the turning point. So it's going to be an increasing function, okay, when, remember, here, x is going to be 0. So it will be increasing if x is less than 0. Okay, right. I hope by now you are aware that the value of x at the turning point is 0. The value of x at the turning point there is going to be a what? A 0. So to the left of the y-axis, the graph is a decrease, is an increasing function, because as the x values are increasing, the y values are also increasing. They will stop increasing at the turning point. To the right of this turning point, the graph is decreasing. So it's a decreasing function when, okay, when x is greater than 0. Okay? Remember, at the turning point, x is 0. If I draw the one with the minimum turning point, okay, obviously we're going to have a q value there, which is going to be negative. To the left of this of the minimum turning point, the graph is decreasing. Okay, so here it's a decreasing function when x is less than 0, and it's going to be an increasing function when x is greater than 0. Okay, so as we approach the minimum turning point, as the x values increase, the y values are decreasing until they stop increasing or decreasing here. There's a decreasing function up to there. Then the x values will continue to increase, while the y values are also increasing. It becomes an increasing function. Also, the gradient is negative to the left of the minimum turning point. It's positive to the right of the minimum turning point. So, if you get a question for a quadratic function asking you for what values of x is the graph increasing or decreasing, your answer must be any one of these four, depending on the shape. If there's a maximum turning point, you must say this one or that one, depending whether you're asking for increasing or decreasing. If you have a minimum turning point, your answer must be x is less than 0 or x is greater than 0, depending on whether you are asked in terms of an increasing or decreasing function. No other answer except these four. Do you hear me? Yeah, if you write something else, I don't know where you go for that from. Right. This is only true in grade 10. In grade 11, things change slightly because of horizontal shift of the grade 10 quadratic function. Right? Okay, let's come back to the example that I wanted to do today. Okay, so let's do that. Alright, so you're given the equation of the quadratic and the equation of the linear. The gradient is unknown, the y-intercept is unknown. Okay, please be aware that the two graphs intersect here. Okay, they were not drawn properly, but they intersect at a common point there. Right? Now, based on the equation of the quadratic, the value of q, the y-intercept, is going to be a minus 4 there. So it's positive 4 rather, not minus 4. So positive 4. Right? So positive 4. Then you may need to determine the x-intercept based on the equation of the quadratic. So before I do 2.1, okay, I need to determine the x-intercept. So I gave you a formula. So x is going to be equal to plus or minus the square root of minus q over a. Okay, I gave you this formula because it makes things easy. You don't have to solve like the quadratic equation. If you want, it's up to you. So this becomes plus or minus the square root. Q is a 4, so you get minus 4, and a is minus 1. So eventually you get this, the square root of plus or minus 4, which gives you plus or minus 2. Therefore, x is minus 2 at b, x is 2 at a. I hope you are following. And I don't expect anybody to get surprised with this, where it came from, because I spoke about that. If you want, you can solve the quadratic equation. So you equate f of x to 0, and remember, the equation is f of x equals minus x squared plus 4. You put 0 where there is f of x, and then you solve this quadratic equation. So you get x squared minus 4 equals 0, and then you factorize by a difference of 2 squares. You get your 2x bar. Okay, you can do that as well. Okay, so you've got two ways of getting the x-intercept. Either use a general formula, or you can solve the quadratic equation. All right. So now that we know the x-intercept, we know the value of the y-intercept, we can answer those questions. So the length of OA, okay, OA is a horizontal distance. At the origin, x is 0. So we use the formula x max minus x minimum. Our x max will be 2, x minimum is 0. So the answer will be 2 units. Okay? Remember, distance or length is always positive. Right? So that's the first one there. Then, get the length of OB is the same thing. So it will be x max minus x minimum. The reason why I prefer to use the formula is because some learners will give you a wrong and negative answer for the distance, which is incorrect. So it's better to just use the formula. X maximum, that will be 0, minus x minimum, that's minus 2. So you get again 2 units. Okay? Then OC, okay, be aware that this point here is point C. Now, OC is going to be a vertical distance. So OC is going to be y max minus y minimum. That will be 4 minus 0. And your final answer will be 4 units. Okay? Right, so I found the length. So you have your horizontal distances, that is OA and OB, and your vertical distance, that's OC. Your final answers must be positive answers, no negative answers, because it's length. Then 2.2 says determine the values of m and n. Now, m is the gradient, and n is the y-intercept. Now, n is very easy to find. Okay, it's a 4, because point C is a common point for both graphs. Okay, so n is equal to q. Okay, so n is 4. So let's find the gradient. So finding n is very simple. M now, we have to calculate the gradient. So we know, okay, we may need to, in this case here, I need you to be aware that the way the graph was drawn, it was not drawn properly. There are two intersection points between the two graphs. Here at C and at A. Okay. There are two intersection points. So at A and at C, the two graphs intersect. So x is 2 here, y is 0. X is 0, y is 0. Therefore, I can use the gradient formula. Okay. Are you following what I'm saying? All right. So m is the gradient, that's the coefficient of x, that's the gradient. N is the y-intercept. You don't always get your y-intercept as a c, please. Okay, it can be another letter. Okay, when you're dealing with functions in this grade, your y-intercept can be another letter. Sometimes even the gradient, it can be another letter besides m. All right, so at A, the value of x is a 2, y is 0. Okay, at C, the value of x is 0 and y is a 4. So the gradient of AC is going to be y2 minus y1 over x2 minus x1. So we substitute, okay, I'm going to consider the point C as my x2, y2. Okay, remember it's your choice. So I'll put 4 there, minus 0 over my x2, that's 0, minus 2. So eventually you get 4 over minus 2, and that gives you the gradient as minus 2. Therefore, m is going to be negative 2. Remember here I'm doing question 2.2. Okay, this is 2.2. Okay, you can also decide and make the coordinates of A your x2, y2. These two get the same result, right? All right, n is equal to 4. Right, I'm not going to do any calculation. Okay, but if you want to do a calculation, you can, but it's not necessary. Because it's just 1 mark for that value of n. Okay, if you want to write a reason here, let's say n is equal to what? And q is a 4. All right, are you following? And then the next question, find the length of AC correct to 2 decimal places. So we now need to find the length of AC, okay, which is more like the hypotenuse of triangle OAC, right? So we know what the length of OA is, we know the length of OC, so we use the theorem of what? Pythagoras. Now be aware that since you are in grade 10 now, the theorem of Pythagoras is now required you to apply it. Okay, you'll never be taught the basics of theorem of Pythagoras now. The application. Okay, so for 2.3, you must identify a triangle. I'll say a triangle AOC, right? So I'm going to have AC squared is equal to OC squared plus OA squared. This is Pythagoras. Okay, my OC is equal to 4 squared. My OA is equal to 2. So my AC is going to be the square root of 16 plus 4, that's 20. But we need to give the answer to 2 decimal places. What would be the square root of 20? 4,1? Huh? 4,47. So that would be 4,47 units. So 2 decimal places. All right. Are you following? Now I'm going to give you some questions. Now we've got 5 minutes, which is more than enough. I'm going to add more questions that you must give in answers to within a minute.